Okay, so deep in the ocean, thousands of feet down in total darkness, scientists have stumbled upon ecosystems that, by all accounts, just shouldn't be possible. We're talking about two incredible discoveries: lakes at the bottom of the sea that are so toxic they kill almost instantly, and on the flip side, these strange potato-sized rocks that seem to be breathing out pure oxygen. So, let's dive into these impossible little worlds.
It sounds like a trick question, right? How can you have a lake inside the ocean? It's already water. But believe it or not, they're real. They have their own distinct shorelines and surfaces, and they are, without a doubt, some of the most extreme places on the entire planet.
And this is where it gets really weird. These underwater lakes, which we call brine pools, are so deadly that an unlucky creature wandering in is killed on the spot. But here's the crazy part: they also perfectly preserve it. I mean, scientists found a crab that had been sitting at the bottom of one of these pools for 8 years, totally intact. So what on earth is going on here?
To really get our heads around these deadly time capsules, we have to look at what they're made of. See, these aren't just pools of regular water. They are super dense, incredibly salty pockets that have bubbled up from massive salt deposits buried deep under the seafloor.
The numbers here are just staggering. I mean, the salinity can be up to 200 times saltier than the ocean around it. They're basically a poisonous soup of hydrogen sulfide, methane, and heavy metals, with zero oxygen. And they're so dense, get this, a 5,000 kilogram research lander can actually float on its surface. It won't sink. It's truly like landing on another planet.
So here's how they kill. It's a process called osmotic shock. If a fish or a crab accidentally swims into one, the insane saltiness instantly and violently sucks all the water out of its cells. It's basically catastrophic dehydration in a split second. Then, because there's no oxygen and because of all that salt, it becomes a kind of natural coffin, preventing anything from decaying for years.
But of course, there's a twist. Well, nothing can survive in the brine. Right on the edge, on the shoreline of this toxic lake, a whole ecosystem is absolutely thriving. It's this tiny, bustling world, all built around a feast of pure poison.
You see, life down here isn't powered by sunlight like it is for us. There's no photosynthesis. Instead, it's all about something called chemosynthesis. Basically, there are specialized microbes that have figured out how to eat the toxic chemicals seeping out of the brine, like methane. They literally turn poison into life. And this creates a really elegant little food chain. The methane seeps out, the microbes eat it, then you have these huge beds of deep sea mussels that crowd around the edge of the pool. They act as hosts for the bacteria, giving them a safe place to live, and in return, the bacteria feed them. These mussels become the foundation for everything else. Shrimps, crabs, even fish come to feed on them. It's a whole city built on the edge of a death trap. This is why scientists get so excited about them. These pools are like a window into the past. With their toxic gases and life that doesn't need oxygen, they're a direct look at what our planet might have been like billions of years ago, long before life as we know it took hold. It's a glimpse of how life might have started. So as if life from poison wasn't mind-bending enough, scientists found another impossible ecosystem somewhere else in the deep sea. And this discovery? Well, it might be even more profound. It suggests a way to create the building blocks for life using nothing more than rock and water.
So back in 2013, a team led by Dr. Andrew Sweetman was out in the Pacific. Now, the basic rule of the deep ocean is the deeper you go, the less oxygen you find. It just gets used up. But their sensors were telling them something crazy. As you can see, down at 5,000 meters, the oxygen levels were actually going up. It made absolutely no sense.
They were completely stumped. Where was this mysterious dark oxygen, as they called it, coming from? There's no sunlight, no plants, nothing. And then their attention turned to the one thing that was everywhere on the seafloor there. Millions and millions of these lumpy, potato-sized rocks called polymetallic nodules. So the question became, could an inanimate rock, a non-living thing, actually be producing oxygen? It sounds completely bonkers, but all the clues were pointing that way. And the theory they came up with was honestly both simple and totally revolutionary. They suspected a process you probably remember from high school chemistry, electrolysis. Right? That's where you use an electric current to split water molecules, H2O, into hydrogen gas and oxygen gas. The big question, though, was where in the world would the electricity be coming from? Well, it turns out the rocks themselves are tiny, natural batteries. They're made of different metals. They have manganese, which acts as a positive terminal, and iron oxide, which acts as the negative one.
And what's the perfect liquid to conduct electricity between them? Salty seawater. The rocks are sitting there on the ocean floor, generating a constant electric field.
When the team tested this idea in the lab, the result was just wow. They were expecting a tiny, tiny electrical current, maybe a few nanovolts. Instead, a single one of these rocks produced 0.95 volts. To put that in perspective, that's more than half the power of a brand new AA battery from a rock.
And that is the final piece of the puzzle. While one rock isn't quite enough on its own, the seafloor is absolutely covered with them. So the theory is, when you have clusters of these nodules all packed together, their combined electric fields can easily get over the 1.23 volts you need to start splitting water molecules and releasing a steady stream of dark oxygen. It's literally an ecosystem powered by rocks.
But this incredible discovery has walked straight into a massive global debate. Because this unique, life-giving environment is now at the center of a huge fight between scientists and big industry.
And here's why. It's because these polymetallic nodules are loaded with valuable metals: cobalt, nickel, manganese. These are the key ingredients for green tech, especially things like electric car batteries. The estimated value of the minerals just in this one part of the ocean is a mind-boggling $17 trillion.
The problem, though, is that this place isn't some barren, rocky desert. It is teeming with life. I mean, look at this. Of the thousands of species they found here, a full 90% are completely new to science. We don't even have names for them yet, and many of them live directly on the nodules that miners want to scoop up.
And that brings us to the debate. On one side, you have scientists pointing to a small mining test from the 80s that wiped out almost 80% of the life in the area, an area that still hasn't recovered 45 years later. On the other side, you have mining proponents like the metals company who say these minerals are essential for the green energy transition and who have called the dark oxygen research flawed, even though they actually helped fund some of the early research themselves.
And this is all happening right now. The dark oxygen study was just published in a top journal in 2024. As we speak, 33 countries are now pushing for a pause or a complete ban on deep-sea mining. And a huge new research project is kicking off to try and replicate these findings and settle the science once and for all. So this story is far from over.
Which leaves us with a pretty profound final thought. For decades, when we've searched for life on other planets, we've focused on the Goldilocks zone, worlds that are just right with liquid water and sunlight. But what if a planet can make its own oxygen from just rocks and water in the cold, black depths of an ocean? Does life really even need a sun? Maybe the best places to look for life aren't worlds like Earth, but in the dark, hidden oceans of moons right here in our own solar system.